Hi, welcome back to the Affinitive Design Podcast. This is episode 8, and I'm David Clayton, your host, and let's get started. This week, we're going to be talking about energy efficiency and the importance of insulation. For this, I've prepared a little presentation that we're just going to go ahead and jump right in. During the month of July, it gets hot in most places in the United States. It gets very hot. In Salt Lake City, Utah, this July has been mostly in the upper 90s and sometimes into the 100s. Go to a place like St. George, Utah, at the southwestern corner of the state, and July temperatures are frequently in the 110s. Temperatures like these make going outside very difficult. Part of the benefit of the modern era is the advent of air conditioning. Air conditioning makes life so much better when those hot temperatures come, but it also comes with a huge problem. Air conditioning uses a ton of energy. Air conditioning is one of the largest factors in increased energy use. Demand for power keeps rising because more and more people throughout the world are gaining access to sufficient income to support this more luxurious and comfortable lifestyle of having electricity and air conditioning. For me, I love that global wealth is increasing such that people around the world are increasingly able to enjoy the luxuries that as an American I was fortunate enough to grow up with. But the cost of this energy keeps rising, and it does have a serious impact on the world. Even with all the renewable energy coming online every day, the vast majority of energy is still produced using highly polluting sources such as coal and gas. Even natural gas, which is the cleanest of the fossil fuels, puts out tons of pollutants into the atmosphere. It came to a head in the 1970s in the United States when an oil embargo and unwise economic policies led to a severe shortage of oil. As a result, Americans got a lot more serious about reducing energy usage. Many architects, engineers, inventors, and other smart people got heavily involved in researching better ways of building our homes and offices to aim at lowering our energy consumption. Ironically, energy use kept climbing because most of these ideas were either poorly thought out or poorly implemented. In the 1980s, as energy prices plummeted again, most people fell right back into their old ways. But the lingering impact of the 1970s was that building codes started requiring buildings to be properly insulated. As time has progressed, many have also become concerned with global climate change. Now, where I live, it is a tricky issue to discuss climate change because most people in Utah are conservative, and the issue has been politicized by both the left and the right. Simply put, Utahns tend to believe that climate change is overhyped and naturally caused. Now, on the flip side, the evidence has been mounting, and it is increasingly hard to ignore that humans do have an impact on the environment. Regardless of the politicization of this issue, it's not as much about the science as it is about the policy implications. Ideally, we can reduce mankind's impact through ingenuity and innovation and implementation of good building science. Building codes, however, have already for years been steering the building industry in this direction of improved energy efficiency. So what is the point? The point is to reduce energy use. The easiest way to do this? Energy efficiency. Energy efficiency is not just about saving the environment, but it also makes financial sense. The more money saved on energy, the quicker the payoff on various solutions to improve energy efficiency. As I mentioned before, building codes have for years been nudging society towards this goal of energy efficiency. In the United States, the building codes used to be a big mess of competing non-governmental organizations producing building code standards for different regions of the country. Since 2000, most states have adopted the International Code Council's standards, with California technically having their own standard, but their version is largely a localized adaptation of the ICC standards that the rest of the country uses. For energy use, this is regulated through the International Energy Conservation Code. At the time of creating this video, my home state of Utah is currently using the 2015 codes. Energy efficiency is achieved in buildings through many different strategies. Most people, though, think of insulation. It is the simplest of ways to improve energy efficiency. Insulation comes in many forms, including organic fills, fiberglass batt, blown-in fiberglass fill, rigid foam or polystyrene, polyurethane spray foam, and even earth. There are many more, but these are some of the most common. Each has its advantages and disadvantages. A good architect knows and understands the value of each and can advise you as to the best use. So let's talk about the insulation of a building. Ideally, the best way to insulate a building would be to create an impenetrable box, an impenetrable boundary of insulation. That way you can create a completely isolated area. But the problem is we have these pesky things called humans that occupy these buildings. The problem with humans is they like doors and windows. So we can't just simply create a hermetically sealed box. So instead, what we do is provide a boundary of insulation around the habitable portions of the building. So in this case, I'm showing the attic as insulated on the ceiling side. Also, any walls around conditioned space would also need to be insulated. Now, if this is a garage, then we would probably insulate this part of floor that's over top of the garage and also this wall here in between the house and the garage. Now, with the basement, we also put a little bit of insulation here on these walls just to keep it a little bit more thermally isolated from the outside. May even put a little bit of insulation on the first couple feet on the exterior of the foundation walls. And then we would also, if this is an unfinished basement, meaning that it's not going to be conditioned, we would also insulate the floor in between. Now, all of this said, we're trying to isolate the habitable spaces that are going to be conditioned from the exterior. Now, here's another factor to consider, is we have earth in this area. So this earth here, this is actually creating some insulation for the basement area, but it's only effective once it's 3 feet deep. So that's why we would add a little bit of insulation for the first couple feet of the exterior. So insulation is not enough. In many buildings, there are doors and windows. Doors and windows create one of the greatest weakness points on a building when it comes to energy efficiency. Glass, for example, on a window, if it's a single paned window, the energy will pass right through. In this example, we're showing a triple paned window. The triple paned windows work so well because in between the layers of glass, there are actually these cavities of dead air. That dead air acts as an extremely valuable insulation barrier because the air is not moving around, so there's less volatility, so less thermal energy is able to transfer across through that boundary. So this is one of the ways that glass can really be improved, is by going double or triple pane. The other advantage to this is that you can also place a layer, maybe 5 atoms thick, of silver. This is called a low E coating. Typically it's applied to either the second surface or the third surface. What that means is, so the first surface is the outer pane, and then the second surface is the inner side of that first pane. So by putting it on the second surface, it protects it from the outside elements, but then it also allows to reflect it back before it gets in to this dead air chamber. Alternatively, you also have the process called thermal bridging. If you have a single material for your window frame, then the energy just passes right through, because most of the times these are built out of aluminum or vinyl or wood, and typically have a very low R value. In this case, though, we're showing thermal breaks in the window frames. Now, these thermal breaks, these are a highly insulative material that creates a joint between the different halves of the window frame, so that as the thermal energy tries to pass through, it stops at these points. Another concern that's not easily addressed through insulation alone is dew point. Dew point refers to the point at which relative humidity reaches 100% and condensation starts occurring as the water vapor condensates into liquid form. Now, this occurs at different points. Relative humidity is based on the temperature of the air and the absolute humidity in the air. So in this example, we're going to imagine up that the dew point is 85 degrees Fahrenheit. On the outside of the wall, the temperature is 95 degrees. And inside, we have our air conditioning running, keeping the home at 75 degrees. Now, on a typical wall with an R19 batt insulation in the cavity, what would happen is this temperature of 95 degrees would start out on the outside. Now, as it crosses through the wall, that temperature will plummet down to the 75 degrees on the inside. Now, somewhere in the middle of this wall is 85 degrees. Now, if the dew point is 85 degrees, then that means right here, that water vapor is condensing. As that water vapor is condensing, that means you have liquid water inside the wall, creating mold. Another concern with insulation is something that happens in cold climates. In cold climates, we get what's called ice dams. During the winter time, as temperatures are below freezing, the warmth of the building rises. Now, if the insulation in the attic is insufficient, then this is going to cause the ice to melt here on the roof. It will flow down, but then when it comes to this point at the exterior of the wall, the heat rising from the building is no longer melting the water. So this water freezes and creates what's called an ice dam. This ice dam stops the liquid water that's melted from insufficient attic insulation and creates a situation where the water flows back up through the shingles, through the plywood sheathing of the roof, and now you have water inside your attic. As you can see, to design a building for good performance requires an understanding of the underlying scientific principles that affect buildings. A good architect will help you deal with these and many more issues so that your building will perform well. So hopefully you enjoyed that presentation. I really enjoyed creating it. I created it largely because I think there's been a lot of people who will ask questions about this, or there are things that they just don't understand about it, and I felt it was important to create something that people could learn from in a very simple and easy to use format. The importance of energy efficiency cannot be overstated, because ultimately we're just throwing money away and wasting energy, and we're polluting the atmosphere as we do it if we keep just wasting energy. And especially as we transition into more solar power and wind power and other renewables, it's going to be really important to be energy efficient on that side as well, because again, you're just throwing money away. Even if we're not polluting, we're still throwing money away anytime we're not being as energy efficient as possible. Now, most of us understand that, and so one of the things that I would add that I did not include in this video presentation is that there are a lot of companies out there going door to door or selling energy audits and adding insulation and things like that. A lot of these companies are actually legit. They're good companies to deal with. The thing that I would look out for if I were you is see what kind of technology they're bringing to the table. Are they going to be doing any thermal imaging scans to see where the leakage points on your home are? Are they going to be doing sufficient insulation? What level of insulation are they adding to the building to actually make it more energy efficient? So those are some of the questions that I would ask. Ultimately, any addition in the insulation will help, but if they're charging you a lot for adding this insulation, you might want to have a second opinion. And that's something that a good architect would be happy to do, to give you a little overview and discuss it with you, just to figure out, hey, is that actually going to be the right move? Again, ultimately, most of these companies are legit and they are good companies to deal with, but it is important to be aware and always recognize that there are scam artists out there. There are people who are not giving you your best interest. So finally, considering the renewable energy side of things, we'll talk about that in a future episode. I don't think it's as important to discuss right now, but it is something to also be aware of, especially with as hot as the solar energy market is right now. So many people are out there trying to sell you solar panels. Be very careful. Be very careful of who you invest in, because a lot of these solar energy companies, they're really out there just to sell the panels. They don't care one flying flip if you're going to be improving your energy efficiency or improving your bottom line. Ultimately, they don't care. I mean, why would they care? They're going to tell you that, oh, we're going to size you a system that's going to sell you exactly how much power you need so that you replace your electric bill. Most of the time, this is false. Most of the time, they cannot actually do this with a high degree of precision. A large part of that is because the power does not sell back to the electric company at the same rate as what the electric company sells it to you for. And so there's always going to be this gap. And then also there's times when the electric company is not going to even accept the power from your solar panels. And so if you don't have a battery system that goes along with your solar panels, it's useless, because Rocky Mountain Power or PG&E, any of these major utility companies, they're trying to limit how much power people can sell back to the grid through their solar panels, because, of course, they don't want to sell it. I mean, they don't want to buy it. They're in the business of selling power, not buying power. So, anyways, this is something that we'll go into more in depth on a future video, hopefully in the near future. But in the meantime, this has been a really fun topic for me. It's something that I deal with every day as I design homes and commercial buildings. So hopefully it's been helpful to you, and I look forward to talking with you this next week. Have a great day.